If you're skeptical about global warming, that's probably a good thing. I'm a scientist, and most scientists are skeptical about most things. However, we can occasionally be persuaded by compelling evidence. Now, there's not any debate among scientists anymore about global warming. The only debate is among politicians. And that being the case, I hope that even if you're skeptical, I hope you'll be open to compelling evidence. Now, before I can give you the evidence, which isn't so hard to understand, I need to talk a bit about some of the really awful things that have been said about scientists. The first would be that global warming was just cooked up as a way of getting more grant money. Well, anybody who says that does not understand how science works. There are 4 reasons why that really can't be the case. First, the punishment for fabricating data or deliberately misinterpreting it in science, no, it's not 5 years of probation. You're finished in science if you get caught massaging the data. Second, science progresses, well, progressively. Each step depends on the step that came before. And if the step that came before was cooked, the next step doesn't work, and that gets noticed. And third, before data gets published, before it appears in a journal, the editors of the journal have scientists unknown to the author have a careful look at the paper and its data. There are also mathematicians who have mathematical ways of examining data for fraud that are really too sophisticated for biologists, for example, to follow. And fourth, and this is most important, science isn't done anymore by individual scientists working in their little laboratories. It's done in big groups. And if you're part of a group of people doing science, and you suspect somebody of massaging the data, you are going to immediately blow the whistle. Because the one thing you do not want in your career is to be one of the authors on a paper that had to be retracted. The only way to survive that is to be the whistleblower. Now, I also hear people shouting about the email messages that were revealed that proved that scientists were cooking the data. Well, when I was teaching at the University of Iowa, the dean of the medical school sent around a memorandum to people for whom English was their second language. And he said, if you're on our faculty and English is your second language, don't try to tell a joke. Your students won't get it, they'll take it seriously, and they're likely to be offended. Now, unless science is your first language, don't look at private email messages. You'll get confused by the jokes. Those scientists have been thoroughly investigated by several outside committees and exonerated by all of them. I also hear people say that, well, global warming is just a model. Well, aside from the fact that there's more to it than just a model, if you're inside, take a look around you. Everything you see is man-made, and it would not exist if it were not for our understanding of the atomic model. Pilots get in airplanes that have never been flown before and take off in them. And they do that because they know there's a computer model that accurately predicts what that airplane is going to do in the air. So, what's the evidence for global warming? While I talk, let's look at this graphic. Each point of light represents the temperature of a weather station. We're starting in 1800 and moving forward to the present. So as we go along, there will be more and more points of light as there are more and more weather stations. Blues and greens indicate temperatures that are below the average for the life of the station. Yellows and reds indicate temperatures above average. Few people really argue over whether the world is getting warmer. It's obvious to anyone. Now, this graph does stop in 2007, and there are a few people who will shout that the world hasn't been getting any warmer since then. Well, it has. It's just that the weather stations you're looking at here haven't been getting any warmer, but we know where the heat has been going. It's in the Pacific Ocean. Recently, changes in ocean currents in the Pacific have been transferring heat from the surface to a region not far below the surface called the thermocline. That heat will start showing up again soon enough. The real question is, what's causing the Earth to heat up? Now, there are natural cycles in the amount of sunlight that reaches the Earth, but those cycles should be causing the Earth to cool off now. There's also the suggestion that an increase in the number of cosmic rays striking the Earth should heat it up. Well, crazy as that sounds, it could be right, except we've been measuring the incidence of cosmic rays for decades and it hasn't changed. So, what is it? Let's start by taking a look at how the greenhouse effect works. Light comes from the sun chiefly as visible light and ultraviolet light that humans can't see. Its frequency is too high. Both visible and ultraviolet light pass through glass. When it strikes the floor of the greenhouse, it warms the floor. Now, all objects give off infrared light. You can't see that either, this time because the frequency is too low. But you can feel it. The hotter an object, the more infrared it gives off. When you feel that an oven is hot without actually touching it, you're feeling the infrared light from the oven warming your skin. So, the floor of the greenhouse gives off infrared light. But glass isn't transparent to infrared light. We could say it's black to infrared light. It absorbs it. So the light is absorbed by the glass and the glass gets hotter. But when it gives off infrared light, half of that light goes back into the greenhouse instead of off into space. There are gases in the atmosphere that behave like glass. Carbon dioxide and methane pass visible and ultraviolet light, but they absorb infrared light. Now, increasing the carbon dioxide in the air of the Earth has to increase the temperature of the Earth. The question is, does it increase it enough to account for the increase in the temperature of the Earth that we're actually seeing? And the answer to that question is yes. And we have two lines of evidence that makes us think this is correct. One, of course, is the models that we've been talking about. Now, if we set these models up using data from the 20th century and then run them into the 21st century, they accurately predict what's happened to the weather so far in the 21st century. And we trust them to continue being accurate for several decades into the future. Now, the models are complicated. They have to account for things like melting permafrost, putting more methane into the air, or raising the ocean's temperature, causing changes in the circulation patterns of the ocean. But being complicated doesn't mean they can't tell us anything. It only means that when we report data from them, we have to report a range of data. We can't just say the Earth is going to raise by its temperature by 5 degrees Fahrenheit. It'll be somewhere between 5 and 10 degrees Fahrenheit. We can also predict the future a bit by studying the past. We do that by looking at ice cores taken from the ice at the poles. As it snows in the poles, the snow is compressed by more snow falling on top of it until it's compressed into ice. Now, as the snow falls during the year, in the summer it has a little less acidity than it does in the winter. So that in the compressed ice, there are layers that are more or less acid, and we can count those layers the way we count the rings on a tree to see how old the ice is as we go down deeper into the ice. Also, as the ice gets compressed, the snow gets compressed into ice, bubbles of air get trapped in there. And by analyzing those bubbles of air from ice that's very old, we can see how much carbon dioxide was in the air a long time ago. We can also use that ice to determine how warm the Earth was a long time ago. Now, to get a really clear explanation of this, you'll have to take a look at the written version of this on my website. But roughly the idea is that as water evaporates in the tropics and moves toward the poles, water molecules have slightly different weights depending on the isotopes in them. And as the water rains, the ratio of the heavy to light water that falls out depends on the temperature. And so the ratio of heavy to light water that reaches the poles depends on the temperature of the Earth, and we can use this to determine the average temperature of the Earth over time. Now, occasionally in the history of the Earth, there have been things that have happened to release a lot of carbon dioxide into the air. Things like volcanic eruptions. And every time we see the concentration of carbon dioxide go up in the air, we see that followed by an increase in the Earth's temperature. And we're talking about increases in carbon dioxide that are smaller than what humans are producing today. Now, I am well acquainted with a number of researchers who are intimately involved in this work, and I can tell you that they are concerned that things may be a good deal worse than what they've told you so far. Now, we only run these models to the end of this century because we don't expect them to be accurate after that. But that doesn't mean that global warming will stop at the end of this century. The carbon dioxide will still be there. And if we do nothing to stop the production of carbon dioxide by human beings, the concentration of carbon dioxide in the air at the end of this century will be very high. How high? Well, the last time the carbon dioxide concentration on Earth was that high, the temperature of the Earth was 40 degrees Fahrenheit higher than it is today.